Okay, so today's lesson we're going to learn a little bit more about pOH. So before we do that, I want to review pH a little bit. And this is a little tricky. So what is the pH of a 0.00123 molar solution of potassium hydroxide? Think about what you have to do to solve that. Okay, the answer is 11.09. That's what the pH is. In order to solve it, you have to use Kw, which is the ion product constant of water, in order to find the molar concentration of hydrogen ions. And then using that, you can find pH, using the pH equals minus log times the concentration of hydrogen ions formula. Now, just like we can look at pH, you can also find the minus log of the hydroxide ion concentration, which we call the pOH. So it's exactly parallel to what we do with pH. It's just now we're looking, instead of hydrogen ions, we're looking at hydroxide ions. So pOH equals minus log of the hydroxide ion concentration. So if we have a hydroxide ion concentration of 0.01 molar, we just plug it into the formula. What are our calculator buttons? We change sign, we hit log, we put in 0.01, and then hit enter, and you should get the value of 2. So basically it's the same process. You just have to pay attention whether it's hydroxide ion, or which goes with pOH, or hydrogen ion, which goes with pH. Now, just like if you have the pH, you can find the concentration of hydrogen ions. If we know the pOH, we can find the concentration of hydroxide ions using that formula. So we have a pOH of 4. We have a pOH of 4. We will select 10 to the x. Now remember that's a second function. And then we'll enter a change sign to make it minus and then the number 4, so look like that. And then hit enter and you should get 0.0001. And that's actually a molar value. So it would be 1 times 10 to the minus 4 molar hydroxide ion. Okay, units of molarity. Okay, now we have the formula for Kw and we have formulas for pH and pOH. I wonder if we can somehow combine these. So pH is minus log H plus, pOH is minus log OH minus. Here's the Kw formula, concentration of H plus times the concentration of OH minus equals 1 times 10 to the minus 14. Now, those of you who understand logs, let's take the log of each side. And when we do that, minus log of each side. When we do that, we get minus log of H plus plus minus log of OH minus. Now remember, these two are multiplied, so we add them together. That's what happens when you're taking logs. And then minus log of 10 to the minus 14, and then we just plug and chug and substitute. Isn't this the same thing as pH? Isn't this the same thing as pOH? And minus log of 10 to the minus 14 should be 14. So this is a really handy formula, as you're going to see, to help us solve problems. So if we know the pH, we can find the pOH just by subtracting it from 14 and vice versa. So here's an example problem. Concentration of NaOH is 3.15 times 10 to the minus 5 molar. What is the pH of the solution? Assume sodium hydroxide is a strong base. Now that's actually important so that we know that all of the hydroxide is in solution. All of it's broken apart from the sodium ion when it dissolved. Now again, we're going to get hydroxide ion concentration here, but we want to get to pH. Well, we can find pOH first. Okay, we know what the hydroxide ion concentration is because sodium hydroxide is strong. We plug that in and we can find pOH, and pOH is 4.5. Now if we use this formula, put in our value for pOH there and then solve for pH, we end up with a value of 9.5. So this is actually easier in many respects than using the Kw formula.